All right, guys, if you do not have out your notebooks, please get those out now because these next slides are all going to be very important notes for you to take. This is kind of summing up what you did yesterday. So each of our 7 functions, please make sure that you pause the video if I'm going too fast and you need to get some more of this stuff written down. So our first function that we've been working with is linear functions. You've been working with these since 8th grade. I have a graph there. Then I have the parent function and the graphing form. So really the parent equation is just when our graphing form equation has 1 as the a value and 0 for h and k. So then when you would simplify it down, it would just be the parent equation there. When we are working with linear functions, the domain and range are both always all real numbers. And you can just write it like that, all real numbers. Some interesting properties, we don't have any endpoints because this graph will go on and on forever. There's no max or min, again, because it goes on and on forever. There's no definitive stopping point. The last one, it says, okay, h and k. So when you're looking at the equation with h and k, that can be any point that is on the line. So in this case, it could be 2, 2, it could be 0, 0, it could be -2, -2. When you see h and k, that is any point that falls on our line. Next, we have our quadratic function, which we also call these parabolic, which makes sense because this is a parabola. All right, the parent equation we have there along with graphing form, and you've been working with this one pretty heavily when we were talking about transformations of functions. Our domain is always all real numbers because we're going on forever in both directions. And our range, when we have a concave up like this, it's always going to be y is greater than or equal to whatever the k value is. So in this case, it's 0, so it'd be y is greater than or equal to 0. If the parabola is concave down or it looks like a frown, it's upside down, you'd have y is less than your k value. The interesting thing about this one is your symmetry is always at x equals h. So whatever your h value is, that's where your line of symmetry is. And there is a minimum or maximum, depending on the shape of your graph, at y equals k. So whatever the k value is will be either your min or max. In this case, it's a min. And as we know so far, h and k in our parabolic or quadratic function always represents the vertex. Next, we have cubic. And again, this is when we have something cubed or to the 3rd power. This graph, this is how the graph will always look. So it's concave up for part of it and concave down for the other. We have both equations written there. Notice it's very similar to our quadratics. Again, the domain and range is always all real numbers because it will be going off into the left direction and the right direction forever and ever. This one has a min and a max. So as you start to work with these, you'll see ones that are a little bit more extreme of a curve, and you'll see that they have both a minimum and a max on each of those. The h and k value is the center point, or basically wherever the graph changes directions. We also call this the inflection point. So right in the middle where it changes from concave down to concave up, that is where our h and k value is. Next, we have rational, which is also called a hyperbolic function. And remember, we called this graph a hyperbola, so that's where hyperbolic comes from. We have both the parent and the graphing form there. Again, so remember, if we were to plug in 1 for a, 0 for h and k, our graphing form would simplify back to the parent equation. Your domain will always be all real numbers except the h value because domain has to deal with x's and h is on our horizontal line. Okay, same with range. It'll be all real numbers except k, so except our vertical there. So some interesting properties. Our vertical asymptote is at h. So there will always be a vertical asymptote at h. There will always be a horizontal asymptote at k. And it is symmetrical, as you can see. So remember, symmetrical means we could fold our graph in half. The h and k is where the asymptotes intersect. So because our vertical is at h, our horizontal is at k, when those two lines would intersect, that is the h comma k value. For our square root function, the parent equation is there along with our graphing form. Your domain is always the h value to positive infinity. Your range is the k value to positive infinity because it's always going in the right direction. There's no symmetry here, but there is a starting point, and specifically our h comma k is the starting point of this graph. Then we have the absolute value function, parent equation, graphing form. Our domain will always be all real numbers because it's going in the left and right direction forever. Our range is y is greater than or equal to k, so whatever your k value is, unless it is reflected over the x-axis, then it would be y is less than k. So again, just depending on the direction of your graph. It is symmetrical, and again, the vertex is where our h and k is. So this is similar to our quadratics in that sense. And lastly, we have exponential. So exponential, we can change the base. So where you see a 2, that could be any other number. We're using 2 just to have a set function here. Our domain is always all real numbers. Our range is always y is greater than k. It will never touch k, so we can't have equal to, because there is a horizontal asymptote at k. With h and k, this is not a specific point on the curve like our other functions, so you don't have to worry about that. All right, guys, so these are our 7 functions that we've been working with. Make sure you have all 7 of these with notes in your notebook. If you need to go back, rewatch, and pause the video, please do that.